All right, so this week is going to be about flow control. Flow control is what we use in order to direct comments and direct code in Python. So if we wanted to do something, then do this. If this, then that, right? It's going to help us clean up a little bit on how it works, and it's also going to help us set up for functions moving forward in the future. You just do a side-by-side here. It'd be easier to get us up and rolling. Okay. So as we're working through that, we use what's called flow charts. And so this flow chart that shows up here, we start our program. We ask a question like, is it raining? If yes, go to this direction. Then we check to do a check to see if we have an umbrella. Yes, go outside. If we don't, wait a little while, then go down. Is it raining? No. Go outside. If yes, loop back over and over again. Okay. So these flow charts can be super handy when you're first doing programming, especially if you guys have never done programming languages, to kind of draw this out on a piece of paper. And as you guys are working on your bigger homework assignments and specifically the midterm project, it's a good idea to have these flow charts of your overall program. It's a great way to keep you from getting lost and making sure that you have all the checks that should be in there for each one. So if you go back to the Blackboard section, you're going to see this thing called Diagrams.net. Diagrams.net is just a free tool that allows you to do flowchart making. So you can create those as a tool, and then you can print them off or do whatever. If you want to do them on a simple piece of paper, you can do that as well. All right. Many students that have taken this class have all liked going through and doing their flowcharts, at least for the first couple homework assignments, so that they get the idea of I have all my checks and balances and I have them in the right order. That's when you start working with if statements, which we're going to go through, you want to make sure you have everything in the right order. Otherwise, an if statement that you go down at the bottom may never get hit, right? Because it matched something up above it, and therefore what you anticipated this to do would never trigger. So it's a great way to check that. We're going to talk about that in this week's homework assignment. So far we've talked about a couple different values. Does everybody remember those? There was 3 of them. Data types, sorry. Data types are values. Strings, integers, and floating points, right? And then we talked about functions of print and input functions thus far, okay? So we're going to add to our data types, and we're going to be using Boolean values. These are simply true and false, right? No, in Python, it's very important that you guys have a capital T for true and a capital F for false. So if you have those in lowercase, that means something completely different. It actually becomes a variable at that point. All right. So you want to make sure you have a capital T and a capital F. All right. So with Boolean true and false, you can set something to true and false. So if you have spam equals true, then from there on out, spam is going to be equal to true. We could do checks against that. We could see if something's in there. So we could say something like true equals 2 plus 2. That's not going to do anything because we can't see if 2 plus 2 equals true, right? What's 2 plus 2 going to give us? 4, which is a integer, right? So that integer is not going to match a Boolean data type. All right. We have comparison operators. This is how you're going to compare one value to the next. So you guys need to know how these relate to one another. That's another reason they use relational operators. So in Python, a double equal sign means equal to. If you use a single equal sign, does anybody remember what that is? All of that. But what is a single equal sign? It's an operator, but what's it called as an operator? Identifying is close. There's a keyword for that one. So if I have a variable and I want to give it a value of 1, I have to what? Assign it, right? So a single equal sign is an assignment operator, where these are comparison operators, and they're different. And the number one that people mess up as they're going through the class specifically is the assignment operator, which is a single equal sign. So if I say value equals 1, that's an assignment. I'm assigning value I'm assigning a variable the value of 1 as an integer. A double equal sign means equal to. I'm checking to see if it's equal to. All right. So if you do your if statements, it will accept the single equal sign. right? Because it's going to be you assigning a variable in the middle of a if statement. It's not going to function like you want it to. So if your if statements aren't functioning like you would expect, make sure you're using double equal signs like you would anticipate. All right. Not equal to is an exclamation point and an equal sign. You have less than, greater than, or equal to, or less than or equal to. All right. Obviously, we can use equal to and not equal to on strings, floating points, integers, but we can only do integers for less than, greater than, or less than or equal to, or greater than or equal to. Does that all make sense? So I can't see if the word Jason is greater than or equal to Sam, right? But I can see if 4 is greater than or equal to 6. Right? So that's how you would use them in your math. This is showing examples again in the interactive REPL, but this is how we would test things in our site. So, and this little blurb here is talking about what I talked about, right? The difference between a double equal sign and an equal sign. So know that difference between the two. Again, a single equal sign is an assignment operator. A double equal sign is a comparison operator. There may or may not be a quiz question about that. So note to self. All right. We also have what are called Boolean operators, and these are used to compare the Boolean values, right? So where comparison operators are comparing a string and a string or a integer and an integer, if we want to compare Boolean values, we have to use Boolean operators. And those are very simple. It builds out little truth tables. So if anybody in here has already taken what you got stats and you've got logic, if you guys have taken general logic, you would understand truth tables. This is also what we need in programming. So we would check to see if something is true and something else is true, then do something, all right? Or we would check to see if this expression is false and true, then maybe that evaluates to something else. So an and truth table means that it's only true if a true and a true exist inside your comparison. That makes sense? I can sometimes lose people on truth tables. So if so, just say so. You're not going to be the only one out of 8 students. A true and a false is false, a false and a true is false, and a false and a false is false. Just meaning that if I evaluate something like 2 plus 2 equals 4, that is what? True or false? True, right? And on the other side of that, I say and 3 plus 3 equals 6. That is therefore true overall, and then it would execute my code below that. All right, and it'll make more sense as we get into our if statements here in a little bit. All right, if it is true on one side and we use the and say false on this side, well, now it is not true and true, therefore it's now false. We do not execute the code underneath of it. All right, if we say or, now it can be true or false, right? So we have true or false and true is all going to be true. The only time it's false is if it's false and false. All right. And then the easiest one is the not operator. That is just the opposite of whatever you said. So if it's not true, then it's false, right? If it's not true, it's true. I just did what's in here on the paper. All right. So you can mix these between. So this is what I was given an example here. You can have something like 4 is less than 5. That is true. And 5 is less than 6. True. And because we use the and operator, that will evaluate to true. All right. And you can get these really long, complicated ones all the way through there. All right. What we really need to know is conditions. All right. And so what we start off with is going to be dealing with blocks of code. So in Python right now, everything you guys have written so far, let me just pull up idle here. Maybe. Laptop's being a little funky with me this morning. Let's see here. Idle. Oh, it's going to be under Python. There we go. Idle. I'm just going to open up one of our previous assignments here. Okay, so as we were working on this assignment, you can see everything is over here on the left-hand side. We would have something like our input, etc., but everything is to the far left. If I tab in and type something, that is considered a block of code. All right. So this is a block and this is a block. And a block is beginning whenever the indentation increases. So this here is considered a block of code. All right. You can have other blocks inside of that code, which means the indentation increases underneath of it. And blocks will end when the indentation decreases back to 0 or the block containing before it. Again, will all make sense here in a second. So if we look at this code here, and I'm just going to copy and paste this in so you can see it. Get rid of some of this as it goes through here. All right, so if we look at this elif chain, we have a name equals Mary, a password is swordfish. First, we're going to check to see if the name is equal to Mary, right? So we have our name, which is our variable, equal to Mary, and this is a double equal sign. So will this end up being true or false? True, right? So if it's true, we're going to execute the next code block that's underneath of it. If this was false, it would go past this and go down to this line, which has nothing on it, which means it's the end of the program. Okay, so we could have something like print end of program. And if in the event we run this program, if name is not equal to Mary, then it's just going to run into program and end the program. If it is equal to Mary, now we're going to run the next code that says print hello Mary. Then we're going to do a check to see if password is equal to swordfish. Is that going to be true or false? True in this case, right? So if it's true, we're going to print access granted. If it was anything else, we are using an else statement for a catch-all that will say wrong password. It doesn't do anything at that point. It just ends the program. So if we wanted to test this, throw this out of the way here, and we run it, we should get hello Mary, access granted, end of program. Okay, so that one came here. It did a check for Mary. We printed it. We checked our password, access granted, then our end of program. If I change the name to equal Jason and we run this, we can see it just immediately goes to end of program because it did this check here. That was false. Therefore, it just went down to the next line of code, which was print end of program. If I change this back to Mary and I change the password from swordfish to say password and run this, we can see that I will get hello Mary, wrong password into program, which means this was true. It went to this line of code, which then checked to see if this was true. It was not. It hits our else statement and therefore prints this out. Does everybody understand this logic flow as we go through the program? Okay. All right. So we have our if statements, as you can see in here. So an if is always going to have the keyword if. It's going to have some condition. In this case, we're checking to see if name is equal to Mary. That's going to evaluate down to either a true or a false. All right, so this condition is always going to equal some Boolean, either true or false. With this condition, we have a colon right after it. And then below that, we have the next line, which is indentated in. So if this is true, then we will execute this code. If it's false, it goes on, unless it have an else statement, right? You can also have an else statement. Else statements are catch-alls. So if this ends up being false, this password equals swordfish, then it's going to catch on this else statement and have wrong password. Note that an else is not required. So for example, in this if statement, we did not have an else down here. Therefore, it did not execute it. So it's optional to have an else. And there's places you do want it and places you don't want it. Okay. An else is only going to have the keyword else with a colon and then print the line of code below that. All right, we can also have what are called elif statements. So for example, if I have if name is this, I could also have an elif statement here that would say elif my name is equal to Jason. Well, then I want to execute some other different code and print you must be better than Mary. I don't know, making this up as I go here, right? So this line of code is only going to get checked if this first if is false, right? So this has to revert to false. Then it's going to go to this if statement and say, is your name equal to Jason? If that's true, it will print this. If it's false, it just continues on with the rest of the program. Or I can have an else, and it could say something like print, I do not have a match for you in my program. Okay? Does everybody see how ifs and elifs work? Now, I can have multiple elifs. So if I want to check for Jason, and then maybe I want to check elif, the name is equal to Sam, right? And we can go there and print, hey, Sam, sure, whatever, right? And I can execute more and more code underneath one of those. Now, obviously, this NAM needs to be named. There you go.
So why didn't you put an elif on the last one? I do not have a match for you.
So this one is because an elif is checking a condition. So name is equal to Sam, where else is just a catch-all. So there's no condition. Yep, if it's not Mary, it's not Jason, and it's not Sam, therefore those conditions are all going to be false. It'll be anybody else. Does that all make sense? Great question. So that's how else's work. They're always the catch-all. If it didn't meet anything up above, it's going to give you this one. And you can choose whether or not you want to have a catch-all here. In this case, it makes sense to give them feedback saying you don't match anybody in our system, but it may also make sense to not give them any feedback on that particular one. Now, as you're executing these programs, does it make sense to use an if Mary, elif Jason, elif Sam, or what if I just started a whole new if chain and did something like this, if Jason, if Sam, etc. else? Well, if I do this, then it's going to check for Mary first, right? Then it's going to start checking for Jason. Well, Jason doesn't matter if Mary failed. So if it's an if, elif, else, right? The first one has to be false for it to go to the next one. That one has to be false to get to the third one. And if that one's false, it gets to the else. But if I have everybody in their own if statement, well, then I check them regardless of whether or not it matched up above. Does that make sense? So to demonstrate that, if I have an if for the Jason and I have an if for Sam, I'm going to check Mary and Jason and Sam. Even if I matched on Mary, I'm still going to check whether or not I match Jason and I'm going to match Sam. There are individual chunks at that point. So that's when you would make the difference between using separate if statements or elif statements, is if you wanted to check in a specific order. So a good example of this, and we'll get to this in our homework, is playing a guess the number game, right? So if I want to see if it's greater than 0 and less than 4, then I give them some answer. If it's greater than 4 and less than 6, then I give them some answer. And if it's greater than 6, then I give them another answer. Well, I have to check those in a very specific order. Otherwise, it's never going to get called in the right spot. All right. And that'll make more sense when we get into the homework side. Does anybody have any questions on if, elif, and else chains? How many if statements are there in one chain? Only one. And is it required? Yes. All right. How many else statements are in a elif chain? One. And is it required? No. All right. No, that's okay. So if statements are always required in an if chain. Makes common sense, right? An else is not required, but you can only have one of those if so. And it only makes sense, right? It's a catch-all. So you can't have two else statements down here that would say else blah, 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 because it already got caught by this catch-all. If you wanted something like this, well, then this becomes not an else, but a what? Elif, right? And that's what an elif is an else if something else. All right. But on this elif, I have to have some condition here, which means it needs to be something like age equals 10 or something like that, right? And not equals 10, I need a double equals so that it actually does the equation. If I say age equals 10, that's going to equate to true. Does anybody know why it equates to true?
Because the single one assigns a value to 10.
Right. And so it's going to say age equals 10. No, it's just saying age equals 10. That will equate to true because that's what we just said it was. Makes sense. We're not doing any comparison to see if it really is equal to 10. We're just assigning age equal to 10. So if you guys have weirdness or wonkiness going in your programs, make sure you didn't forget that second equals. Yeah.
Are you able to check if it's like an integer or a string?
Yes, you can. So what you could do is you could do some like divide it, right? So you could try to divide it, and if it doesn't divide, then it would end up being like a string, which will actually error out and do that. So there's better ways to do that check, but yes, there are ways to do that. Yep. So we're not quite there yet, right? So if you remember in the first homework assignment, I said, hey, at some point we're going to be able to do checks and balances. We're going to be able to do some checks, but we can't do a full check at this point. But we can check to say, you know, input equals name or name equals input. We gather their name, and then we say if name equals a specific name, do something. If we say enter your age, and we say if age is not divisible by 1, which is a way for us to check if it's a number, right? It's going to actually fail. The program will crash at this point. We can't say, is it an integer? Another way we could do that is say, let's do this. So if we say print, what is your age? Something like that. We have age equals input. Just give it some kind of prompt here. And then we could say if int age, right? Because that will allow us to take whatever they typed in, convert that to a number. And if that works, then we print thanks for putting in a number. And if we did something like an else and print something like that is not a number, this is how we would expect that logic to work based on what you're talking about. The problem is if I run this and I put in an age of say 32, it's going to work. It's going to say thanks for putting in a number. But if I give something other than a number like that, it's actually going to crash the program and never execute our else. So if I zoom back up here where you can see it, notice that it immediately crashes because we can't convert ASDF to a number. So in this case, you would have to use a different thing, which is called a try and except. We get to that later. So the answer is yes, we can do some check, but if it doesn't match the check that we wanted, it'll actually still crash at this point. All right. So if elifs, and then part of that, so if is required, you can only have one of them. Else is not required, you can only have one of them. How many elifs can I have? A lot of them, right? So it only makes sense to have a certain amount of elifs based on what you're doing, because at some point you can only have so many conditions, right? So for example, if I'm playing a guess the number game between 1 and 10, what's the max amount of if statements I could have? That was a trick question. If I'm playing a guess the number game between 1 and 10, what's the max number of if statements I could have? 1, right? Because you can only have one if. What's the max number of elif statements I could have below that then? 9, right? Asking for what each one of these numbers are. But I could also have elif statements that would have something like, is it less than 0? Is it greater than 10? Right? So there's technically more that I could have on top of there, because you may want to check to say, well, that'd be a great Boolean, right? Because if it's less than 0 and greater than 10, we should check that on one line, because that would give us true and true. Then we can tell the user that number's out of bounds. That's not between 1 and 10. Yes, we could do 2 separate checks, but it would be better to put that on one line and make sure it's greater than 0 and it's less than or equal to 10 or less than 11, however you want to write it. Everybody got that? Cool. So you're going to see all these in here. Definitely follow these flow charts, see how it works. So that's what Alice is going to do here. If I have a name of Carol and an age of 3000, if my name is equal to Alice, then do all this. Well, that's going to be false because the name is set to Carol. Then we check to see, is age less than 12? Is that true or false? False, right? So then we come down here. Elif age is greater than 2000. That's true. So we're going to print, unlike you, Alice is not undead and mortal vampire, right? Notice though, this check below it that says age is equal or greater than 100, right? What's the problem with this one?
That's all. It's saying it's over that.
Right. This one is only going to hit when.
When it's not greater than 2000.
Right, it has to be greater than 12, but not greater than 2000. And it has to still be greater than 100 in order to match. But if I put this as less than 100, what would be the problem with this chain?
No.
It would never happen, right? Why? Which one of these would hit first?
The Elif 12.
The less than 12 one would hit first, and therefore you would always get this block of code executing and never this one. All right, so that's why shifting these in the right order is important, because you want specific ones to be executed before the ones below it. So when you're building these out, you always want to make sure that this case above isn't going to get triggered. And you guys will figure that when you start running your code and like, I can never get to the one I want. Well, it's because it's down at the bottom of the chain and it'll never get hit. All right. So there's our immortal vampire exercise, blah, blah, blah. All right. Those are if statements and if, elif, and else. Anybody got any questions on those? Okay. And we're going to keep moving on. We have while loops. So while loops are like if statements in that we have a block of text. So we'll have something like while, let's say I'm going to put an age up here. Age equals 1,000. Okay. Or there we go. While age is less than 1,000, then we do some code. So we're going to print you are over 1,000. I don't know, something like that, right? And if I run this code, what's going to happen? Nothing happened. Why did it not happen?
It's not equal.
There you go. So less than or equal to 1,000, or greater than and equal to 1,000 rather. And okay, that loop is going to go on indefinitely. It's never going to stop. All right, just boom, 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 going to run on forever. If you do this, you have to hit Control-C on your computer. And if you don't do it fast enough, it just flat out crashes. So make sure that you stop it at some point. All right, close the program. I crashed my program. So if you get stuck in that infinite loop, Control-C is how you get out of that loop. If you're lucky enough and you caught it early, then it would stop it. If you go on too long, it probably crashes the program. All right. Let's go back and load up what I had before here.
What would you use that for? Like, what's its purpose?
You don't do it intentionally, but it does happen if you start coding and you forgot to have a way out of it. So that's a great question. We have while is our keyword. We have our condition. If that equals true, we execute this code. If for some reason this does not equal that anymore, say age changed to that. So for example, I could say age is now equal to 2,000 or 20,000, doesn't matter. I run this code. Well, then it executed the first time and then the program stopped. Why? Because it ran this, we changed to age. Age is now greater than 2,000 or 1,000, therefore it stopped running the code. This equals false, and therefore it no longer executes any code, it goes on. All right. Now, you could have this, and this is our block. However, we have ways out of while loops. We may have something like a break, all right? And a break will kick us out of that while loop if it matches some condition that we want, without this having to be up here. So one example of this is the one that they have here. Just copy this in here. Actually, I'll code it by hand because it's faster. Name equals nothing, while name does not equal your name. Print, please type your name. Name equals input. And here we're going to print, thank you. Okay, so if we look at this and I run this code, and if I say, please type my name, I type Jason, and it's still stuck in the loop, right? Sam, Bill, Bill, etc., right? So how do I end up getting out of this program? Why is it not accepting my name?
Because you use the string.
Because I used what? Let's look at that code. Why would it keep me in this loop forever if I'm typing in the name, right? Jack.
There's nothing to stop it. It needs to be with it.
There you go. It's the annoying loop, right? The only way you get out of here is if you actually type your name. Then it'll say thank you and get you out of there. So silly demonstration, but the idea, the reason it does this is because we're checking against specifically the text your name, right? We're not just asking for an input, we're saying your name. Anybody got any questions on how that works? So you can do these. I recommend, and a lot of stuff that you'll do in here is use while true. So what's the problem with the while true? While true means that it's going to go on forever, right? There is no way out of it because it's always true. And while it's always true, it's always true. So while true is true, which is probably going to be the case for the end of time, it's going to run forever. What this allows us to do, though, is it allows us to set up a prompt. So earlier, when you said check up names, we could do something like, while true, please enter your name, right? We get a name from input, and then we could do a check and say, if name, we could do it this way. If string of, well, it's already a string. If, well, let's do age. Age is easier. Okay. So age, if int name, let's change this from name to age so we're not all confused as to what we're talking about here. Get rid of that. Int age. Then print that is a number, right? And then we have our else, print, thank you. You actually just take this code down here. Sticker up here. Okay, this is going to run forever. So if it says type in an age, I do 32, it's going to go in forever, right? And the reason is I get this at print that is a number, but then it's going to execute the code and just stay in this loop. So to get out of that, I could do a break, right? And so now if I run this code, ask for an age, I put in 32, it says that's a number and it ends the program. So that break gets me out of the while loop. There is an implicit continue if it does not match. So if I have a continue here, continue just means start this while loop back over again. So if any point in time I want you to start the while loop back over, I just use the keyword continue. All right. There's an implicit one at the very bottom of this code so that it tells you to loop this back over. So I don't have to have a continue unless I specifically need it there. A break is the only way to get me out of this while true. Well, why is that handy? Because that way we can check to see if they typed in something we wanted, and we only let them out of that loop if they typed in what we wanted. Now, the obvious issue with this one here as it's written is if I put in JSON, the code's going to break right now. But you guys will have a way to fix that later. Okay? Anybody have any questions on that? So one way that we could check this is we could put, please enter a gamer tag. I don't know. Enter a gamer tag, right? Greater than 10 characters. Okay. We asked for this gamer tag. And we have this gamer tag. So how can we check to see if that gamer tag has at least 10 characters? Len, right? We have the len function from before. So we could say if the len of gamer tag is greater than or equal to 10, then we can say that is valid. And we'll break out of this little question block. If it's not, then we can say something like print that is not at least 10 characters. Please try again. Okay, so we run this little bit of code. We put in a gamer tag, ASDF says it's not 10 characters, try again. Yeah. There we go, we got over 10 characters and now it's valid. All right. Does everybody see while these while loops are handy? So anytime you have an input from a user, I always recommend you put that in a while loop. Why? So you can make sure you get valid input from the user. Now, we don't have to tell them it's valid, right? We could just continue on with our code. But if we want to specifically make sure they put in a gamer tag of 10 characters, then we need to do a check against that to make sure they're typing something in, not just continue on the program and tell them it's wrong. That's what you guys would do based off the homework that you guys know so far, or the homework assignments that you've done so far. All right. So that is a while loop. The only way out of it is to use a what? Break statement, right? Or if you're using one that has a while x is greater than 1, so we could say something like this: if x equals true, then we can say while x, right? And then down here, at any point in time we want to break out, all we have to do is say x equals false, and that would also kick us out. But that only works when we use a while x. And in order for that to work, we have to specify our variable up above. So a while loop is a finite number of times, or is a potentially infinite number of times in the loop, right? It's only until we break out of it, or this condition matches false. Another type of loop is called a for loop, all right? And a for loop is a little bit different because a for loop has a finite number of times we're going to go through that loop. So if I say for, and then I have to give it some variable name. Now I can give it whatever variable name I want. I can say for number in, and then I can use something like the range method. So the range method's new. We're going to use range. I want a range, as you can see here on the screen. It starts at a number, stops at a number, and then it has a step number. Okay. So if I say for range of 1, 10, that means I'm going from any number from 1 to 10, but not including 10. All right. It just goes up to 10, but does not include 10. This is tricky because you're about to learn a couple of these that either include the last number or don't include the last number. And you got to know which one's which. So range is up to, but does not include. So from 1 to 10, we say print number. Okay. So let's try this little line of code. We run. And so the first time it runs through here, 1 is assigned to number. Okay. So we print that. Then we go the next time through the loop. Now number is equal to 2, then it's 3, then it's 4, then it's 5, all the way to 9. Notice how it does not include 10. All right, does everybody see how a for loop works? Normally, instead of range, you would pass this through a list, or for those of you that came from other languages, it would be like an array, something like that. Okay, we're going to talk about lists here coming up next week. But for now, we just have a for loop that ranges us through here. If we want to print that, we can use the word number. So we can say the number this time is, and then we could say number, and that is going to be an integer. So we want to convert that to a string. That number there. I got to go back and actually make this a string. Okay, so this makes it a little easier to see. Where the first time it goes through, it's a 1. This time around, it's a 2, a 3, 4, etc. Okay. So a for loop allows you to loop through something specifically, and there's a finite number of times. In this case, there's 9 because we start at 9 and 1 through 10, right? But not up to 10, but not including 10. Does everybody understand that? What would be the equivalent while loop for this? Does anybody know how we could do that? What's that?
Can you say it again?
So what would be the equivalent while loop for this for loop?
While number less than 10.
Okay. And we got to start off with number being something, right? So we would say something like number equals 1. Okay. So inside of this loop, we could print the number and go through. What do we need to do after this line that we printed? Add 1. So we would say number equals number plus 1. Right? So now if we run this code, you will see it looks exactly the same all the way down to 9. Bring it up here. You can see it looks exactly the same. That is the same as our for loop, which looked like that. Does everybody see how we got there? We had to define what number was to begin with, right? We had that as 1. We print that, and then we need to actually add one to number. So number equals number plus 1. These two are the exact same. Now, the problem is this requires a lot more lines of code, right? But for loop is exactly the same in that we're defining number in our for loop, and we're going to feed it a range of 1 to 9. Now, it turns out range of 1 to 10 here is actually going to generate a list, and then it's looping through that list. So this will make a whole lot more sense when we talk about lists here next week. But for now, we're just interested in this range command. All right. So that's our for loops, that's our range loops. Now range, we have a couple different options there. We have the start. So 1, we're specifically telling it to start at 1. We could tell it to start at -10, in which case if we ran this, it's going to start at -10 all the way up to 9. All right. So we have the start, the stop. The only one that's required is the stop. We got to tell it where to stop. If we just put range of 10, it's going to assume that we start at 0 and go up to 10. Okay. We also have the ability of giving it a step. So say we want all of the evens. Well, then we would count by what? 2s. So we would put 2 in there for a step. Now we started at 1, so that won't quite work. We need to start at what? 2. So if we run this code here, you'll see that we get 2, 4, 6, 8 up to 10, but not including 10. All right. If we wanted to include 10, what would we have to adjust on the range? Go to 12.
What would include 11? So you have to put the 10 to 11, right? Well, it's going by 2s.
So we're starting at 2. We wanted to include 10. So if we put 11, that would get us our 10, right? There we go. All right. So you always have to go 1 higher than what you're looking for because it goes up to, but does not include. Yeah.
Why doesn't it? Why does it include the bottom? Like, why does it include the 2 but not the 10?
So the 2 is where we start. So that's your starting number. And then the second one is where we want to go up to, but not include. All right. And the third number is what step we want to go by. So by normal, step is equal to what? 1, right? So we can set it to 2. We can set it to whatever. If I do by 3s, we can execute that code and we see it runs by 3s. So 2, 5, 8. So this can be handy when we're wanting to build out numbers or wanting a certain loop or iterations through something. That's what the for loops are for. All right, that will take you through the end of this section. The last topic that I want to talk about today is importing modules. So as you guys are using things in here, we had the range command and we have the print function and the input function. Those are built-in modules within Python. All right, or those are built-in functions rather within Python. If we want to use something more than what's built in, we have to import extra modules. So say we want to do something like the import random module. This allows us to build a random number. So if we want to say number equals random.random int, and we have to give it a number, so say 1 to 10, then it will give us a random number between 1 and 10. We can print that number. We can see when we execute it, it gives me a 3. If I run it again, I get a 5. If I wanted to do this, say 10 times, I could do something like for what? Something, right? Doesn't matter what. Let's call it number in range of 1 to 11. Then I will calculate what this is multiple times. In this case, we don't want to use number. Let's just use I. Doesn't matter what we put here, right? But we don't want it to interfere with this number that we're printing. So if I run this, it's now going to print me 10 random numbers down below. Everybody see how that works? So that's the random module. We have to import it in first. Then we call it by the module name, followed by the function that we want to use. Yeah.
If you wanted to do that, but instead of giving us 10 numbers, we just wanted to give us 1 number, how would we do that? Like 1 random number. Like say we wanted to.
So that is just this. Don't do it in a for loop. Just say number equals random number between 1 and 10. We did that. We just did it 10 times. Does that make sense? Now, this random int will give you a number between 1 and 10, including 10. This is the one that gets confusing. All right. So you have range, which is going to be up to and does not include. Random integer is going to go 1, including the last number. Memorize those two. May or may not be on a quiz. All right. So that'll get us up to there. We will cover the rest of this and other functions like the sys module and such on Thursday. We'll also start in on the homework. So you guys can start on your homework, but if you really want to wait till Thursday, that's not a problem. We're going to get you a jump start on the homework. All right. Anybody got any questions? Is everybody able to see the videos okay on Blackboard? All right. Those should be posted usually by the end of the day. All right. Anybody online got any questions? All right. We'll end it there and we'll see you guys on Thursday.